and welcome to our online session. My name is Miriam Emil. I'm an Associate Dean at UTS, and I'm here to introduce today's information session. So today, 4th of November, is a bit of a historical day, of course, and for a number of reasons. And one of them is that we have you all here today to discuss the new associate degree in advanced manufacturing, which UTS is developing. First thing first, I would like to acknowledge the traditional custodians of the various lands on which we are all working from today. And for those on the UTS campus, because some of us are there, I would like to also acknowledge the Gadigal people of the Eora Nation and pay respect to the elders, both past and present, as the traditional custodians of knowledge for this land. So in just a few minutes now, you are going to hear from our panel of experts, their perspectives on the degree's national relevance and how it can support employees build up their careers in advanced manufacturing. But for now, it's time for me to introduce you to our MC, Rob Jarman, Associate Professor in the Faculty of Engineering and Information Technology at UTS. Rob gained a certificate in electrical engineering at the Sydney Technical College while completing an electrical drafting apprenticeship. And then that followed with a BE Electrical and a grad cert in education and a PhD in engineering at UTS. So his research areas include engineering education and renewable energy in developing communities. So now I'll hand over to Rob to take it from there. Thanks, Rob.
Thank you, Miriam. Thanks for the warm welcome, and hello, everybody, and welcome to this session. I'm very glad that that little bit of my bio, that I started off life as in an apprenticeship, has actually stayed in here. I sense that that background, at least for my career, has set me up very well, and really, I think this is an opportunity to kind of go back to where I started off in my career, at least anyway, with this kind of model. So we're quite excited to be able to present our thinking so far. But before I start that, a little bit of housekeeping, which I think will be helpful for everybody. If you are new to Zoom, then I'll draw your attention to perhaps the top right-hand corner of your screen. There is a view button up there. And if you can use that to have or to choose what view of the screen you have. The speaker view is perhaps the best because it allows you to be able to see who the main person is speaking at any one time. But that's something for you to choose. Everyone's doing this exactly right at the moment. You've all got your microphones on mute, which is terrific. So thank you very much for doing that. And that will just help reduce any background noise that might come through that you might not wanted us to hear. We'll certainly have this as a conversation, and as best as we can, we'll use the raise hand button to ask those questions as we're going through. And to access the raise hand on Zoom now, you go to the participants icon. That's right at the bottom of the button of the screen. If you press participants, you'll get a listing on my screen, at least it's down the right hand side. And at the bottom of that panel, you'll see a blue raise hand button. So if you want to ask a question, please use that. Otherwise, we'll see how the conversation goes as we're going. And on that point, today really is a continuation of the conversation that we've started, and it seems like we've travelled very rapidly to get to where we are now. We've worked quickly, rapidly with the department, the DESE, and planned, and we understand many elements about our program going forward. The 2-year full-time associate degree. Our commencement date is the 22nd of February 2021. It seems like just a few weeks away. But we know that there are some unknowns, and today is really about continuing to co-construct that program with our key stakeholders. That includes industry, of course, as well as potential students. So welcome to all of you, and thank you for the representatives that have signed up. We can see that there are people from Siemens, of course, and there's Nicolette is going to be speaking later, BEA, Downer, Tullis, Honeywell. I know we've got TAFE here, and of course we can see, well, we hope, a whole bunch of students that have joined up as well. I'm just going to put into the chat box shortly a link to our main ADAM site. I'm sure you may have seen that elsewhere, but that will give you a ready-click link to find out further information. It will be one of the channels that we use to communicate with you further, as well as our ADAM, our advanced associate degree in advanced manufacturing email site. So stand by and I'll post those in a moment. But without further ado, I'd like to introduce Zach Kostasek. Zach is the Director of the Tertiary Policy Branch in the Higher Education Division of the Australian Government Department of Education, Skills and Employment. And it was through his department and Zach's efforts that we've secured funding, and that UTS is part of this partnership around the country with this program. So Zach, are you on board and ready to present?
Yes, thanks Rob. Hi everyone. I'm off mute, aren't I? Can you hear me? Sorry, we're on the phone. We couldn't get Zoom working. So
you're doing great. Well done, Zach.
Okay,
continue.
Great. All right, thanks Rob. Thanks everyone. Great to be able to talk to you all. So we are, as Rob said, we're managing the rollout of this particular program. It involves UTS and a number of other universities around the country, and is part of a broader, really two broader government agendas. One is around testing a model that we're calling an advanced apprenticeship model in higher education, which I'll explain a little bit more in a minute. And the other is just grappling with the changes that everyone expects to flow from Industry 4.0 and you know, the impact on various industries around Australia, particularly on the advanced manufacturing sector. And so this trial is focused on both of those things. It was originally announced at the end of 2019 as a one-year program, and of course, you know, COVID led to a lot of rethinking and reprioritising within the sector, and as part of that, the program's been extended to a two-year program which can support up to a full associate degree, as Rob and Miriam have just explained. So that's what we're looking at now. This is a pilot, so we are testing a new model of higher education, which is this advanced apprenticeship idea. So what makes this different to a traditional, you know, university course, which is more or less delivered to, you know, students full time, many of them school leavers who, you know, they may work on the side, but essentially they're full-time students. This model of an advanced apprenticeship is intended to test models that are delivered, it's higher education delivered to current employees, specifically relevant to their current job or broader industry, and delivering skills directly to them that are intended to be useful both to the student from a career progression point of view, and also to their employer in terms of gaining access to new skills that they can make use of more or less in the immediate term. So these are new models. There have been a couple of smaller scale trials previously testing the way this can work. And we're very excited now to be testing this with UTS. And there's plenty of scope to look at designing the way this thing would work so that it suits the three parties who are involved here, which is the students, the employers, and the provider. So in terms of, from the government's point of view, the precise model and precise arrangements around study time, etc., are something that is up for negotiation between employers and UTS. We're really keen to be quite flexible and support anything that delivers on the core objectives of the program around that higher apprenticeship style model and delivering Industry 4.0 skills. The one thing to be really clear of in the beginning is the name. It's called an advanced apprenticeship, but we need to really understand it's not a genuine apprenticeship. sort of need to imagine invisible scare quotes around the word apprenticeship. The key difference is that this is not a legal employment contract like a traditional apprenticeship would be, where there are mutual obligations, on both sides, and there's a very significant infrastructure, around trade apprenticeships. This is really, I guess, inspired by that arrangement, but looking for something that's a lot more flexible for both employers and students, and doesn't require, I guess, the length of commitment and the legal lock-ins that the traditional apprenticeship system, which has evolved over a very long time, does. What the model is intended to do is provide those skills that I talked about before, but also foster genuine collaboration between employers in industry sectors and higher education providers so that they can work together to really deliver the skills that workers need and businesses need more or less immediately. And so I guess close the gap that some people, commentators talk about a lot, where delivering job-ready skills straight out of the higher education system, is a perpetual challenge. So I guess this is really mostly framed around a kind of lifelong learning, upskilling approach. There's nothing to preclude, brand new employees from being part of this. That would be fantastic as well. But I guess it's a flexible model, and we're really interested in looking at the kinds of models that can be created under a program like this to make these concepts of tailored industry relevant education workable and hopefully one day scalable. Yeah. So the other thing to be really clear about is that, again, in contrast to a traditional apprenticeship, this is a higher education program. So the qualification that we are supporting, in contrast to a vet certificate, this is a higher education certificate, which our colleagues from UTS will explain in a lot more detail a bit later on. One of the things we really recognise here is that we're asking for a degree of commitment from employers here in terms of, at minimum, supporting the kind of flexible arrangements that would allow their employees to participate in the education. Now, the details of how that will play out probably vary by institution, and again, Rob and Miriam and others will go into that a bit later. But we do recognise that that is something new, and I suppose what we're very interested in is hearing from you all what the issues would be around that, and within the parameters of our authority from government, what we might be able to do to facilitate that and support that together with our UTS colleagues. So look, I think that's probably enough from me for an opening remarks, Rob.
Thank you, Zach. Very much appreciated, and wonderful to hear the flexibility of it. I think that sets us up very nicely for how we're going to continue on, not just to work with you, but to also work with everyone here that's a key stakeholder. Nicolette, I think I'm going to throw to you next. I'll give you a little bit of an introduction. So Nicolette is the head of HR at Siemens Pacific region, and she's passionately participated in the Industry 4.0 task force to support the creation of a roadmap to prepare Australia for the future of the fourth industrial revolution. She's consulted with the Australian government and the Victorian government on national priorities, as well as co-creating the Industry 4.0 apprenticeship pilot program, and that was with Siemens and Swinburne. So she's got a fair bit of experience in this before. Nicolette, welcome.
Thank you so much. Thanks for the opportunity. Really appreciate it. Can you not hear me?
Yes, we can hear you fine, Nicolette.
Okay. Sorry.
Yes, I'll let you continue speaking.
Okay, so yeah, thank you for the opportunity. I think it's so important. When I looked at the and maybe I should have told you to correct it, but it gives me an opportunity to talk about it, is that actually we should talk about skills in a broader context when we talk about the Industry 4.0 and the future of advanced manufacturing and the future of industry, really. And that's, we rather should talk about capabilities and competencies. So it's a broader topic. And that's why the apprenticeship model, or a model where you have curriculum and practical experience together in a almost two-thirds, one-third point of view, it works better, because you are actually training people to think. You're training people to solve problems rather than give them the theory, and then they land in the workplace, and then they have to be trained in how to do the role. We've seen with the pilot that we did with Swinburne, those first, if I can just talk about the first group of kids who, and they actually were not all kids, but let's call them apprentices, although, you know, as Zach just said, that's also a loose term. I think it's also got a bad connotation in Australia. So let's rather call them trainees. So those trainees who came through the workplace, where they are today, the titles that they have after 3 years, after the start of our pilot program in Swinburne, is not the job titles we had then, and it wasn't the jobs we would have even imagined that qualification would create. So they've kind of self-created those jobs because of the competencies that they bring to the workplace. And I think this is what you are trying to do when I look at Adam. I think that's what you call it, which, by the way, there's a really cool connection there between Adam. We have to go back to Adam in terms of how we train people up. And we really need to get past this apprenticeship stigma that we have in Australia. It is about practical training and theory. We shouldn't throw degrees and good theoretical PhDs and degrees out of the window, but it's so important that we train and we educate the incoming flux, or the change in skills, that we educate them in a practical way and not only theory. Not only will we include more people in our grab of who can do this program, we would also include a more diverse group of people. So you open for a different group of people that could come into the workforce. And I can tell you, when you look at the studies we've done as Siemens globally, from an advanced manufacturing point of view, it will create more jobs than it shed. No matter what you read, you know, these days you can find anything online that will tell you how many jobs, Industry 4.0 or the digital revolution will shed. It will be more jobs that will be created. And the very big question is, are we going to be ready? And I think this model, these type of apprenticeship training programs, call it what you will, any work integrated learning kind of program that we develop, give people the competencies that can use their skills and their abilities in the workplace as they go. The biggest focus for us in the apprenticeship program was soft skills, not the technical skills. We always say, you don't need to train the technology will come. The technology, the one thing that we know for sure is that advanced manufacturing will come. Look at the Dulux factory that we supported from a Siemens point of view in Melbourne. Digital manufacturing is here. The technology is here. The question is, can Australia answer with the capabilities and the competencies in our workforce to answer that question and actually play on the platform of advanced manufacturing in a global sense? And I think what you guys are doing is an absolutely step in the right direction. I want to talk to one thing, and then I'm almost at 5 minutes, so I won't go longer, I promise. But I want to talk to the employers, and what Zach was saying, it does question employers. As employers, we always sit around the table with the Department of Education and with universities and say, you don't give us the people. Where are these people? And the universities say, well, the schools are not educating the maths and science correctly. All these girls fall out at year 4. And we all criticize. And then the school says, well, the parents are giving them pink trains to play with. No wonder there's no women in the rail industry. So everyone criticized the previous generation or the previous supply chain. And it's time that we all play a role. And I think these type of education setups like Adam gives a platform for once for the university or the education sector, the government, and companies and employers, medium, small, large. It's easy for us to talk in a Siemens and the large organizations, but we need to engage that small, medium enterprise as well. But it gives a unique opportunity for all those stakeholders to play towards the future of skills and how we close the gap together. Because only if we work together with one goal will we connect ourselves to the advanced manufacturing future. The universities will not be able to do it by just training in degrees. That doesn't help as employers. We keep on saying, well, give us any degree and we'll retrain it. We've got to work together. We've got to co-create and we've got to co-educate so that we can get the right outcomes for the future of Australia. And then Australia, with its high level of innovation and its spirit, I think really can play an awesome role in advanced manufacturing, but it's going to all come down to skills and capabilities. So I hope that gives you a bit of an intro. I'll obviously stay on for the duration. So if there's any questions or there's any other questions from the panel, we've been through it. We've worked through the pilot. It's 3 years later. There's a lot we've learned. There's a lot we would have changed, but it was highly successful. And if you meet those 20 people today, none of you would guess that they did an apprenticeship program. You would think they did an honors degree somewhere. It's quite astonishing what they've achieved. So that's all from me for now. I hope that sets the scene for some of the discussion.
Thank you, Nicolette. Thank you very much for that inspiration, or for that lead off. I think you've absolutely brought the experience that you have to this. I will actually pause there just for a moment and see if there are any hands up. The other thing is that I encourage you to use the chat box if you wish to type a message, if you'd rather not raise your hands. But are there any questions for Nicolette just before we progress further?
What I'll do, Rob, is I'll keep my eye during the presentations on the chat, so I can also answer there as there are questions, so it makes it fluent.
Yeah, wonderful. Thanks, Nicolette. Okay, but without further ado, I'll move on to Jochen. Jochen's our Director of the Centre for Advanced Manufacturing at UTS. He graduated with mechanical engineering and PhDs from Germany. And he's held senior management positions in the Bosch Group in Germany and Australia before joining TU Dortmund University in Germany as a professor and head of the Institute for Production Systems. And he holds a dual appointment with that university as well as UTS. Jochen brings clearly a wealth of experience into this and can perhaps paint a view not only of advanced manufacturing as you see it, Jochen, in your experience, but also what might be perhaps for Australia. So over to you.
Okay, thank you very much, Rob, and good afternoon, ladies and gentlemen. Thank you very much for joining us today. So let me share the slides we have prepared for today. Can you see my deck of slides now? Excellent.
Yes.
So I would like to give you a brief introduction to advanced manufacturing, which is actually a generic term comprising new technologies, not only emerging in the manufacturing sector, but in almost all sectors of industry. And for motivation purposes, I would, sorry, it's a bit, I'm in Germany, sorry, it's a bit slow. For motivation purposes, I would like to take a look at the recently emerged World Economic Forum Future of Jobs report. And the key question is, which technologies are likely to be adopted by 2025, which is just in the next 5 years. So I have highlighted 4 technologies which are in line with the research focus of UTS in the area of advanced manufacturing, which is the Internet of Things and connectivity, artificial intelligence in industry, robots, in particular industrial robots, and last but not least 3D, respectively additive manufacturing. And as you can see, in all these 4 fields of technology, there's quite a gap here when it comes to the current state, which was 2018, and the demand for 2025. So that's exactly one reason why we are addressing these technologies in our research and training activities at UTS. So looking at the global manufacturing sector, and this is only the manufacturing sector here, we can observe a different ranking of these technologies. So from a manufacturing perspective, on the very top, there is connectivity and the industrial Internet of Things, and which is one of our key research focuses at UTS, and I will go into further details later. And of course, there's automation, and one foundation for that is industrial robotics and collaborative robotics in particular. So these are the two top-ranked technologies. But there's a fair demand for additive manufacturing as well, and artificial intelligence. And this is quite significant, as when we move and take a closer look at Australia now, which is from the same report, we can see a different perspective. So this is not only looking at the manufacturing sector in Australia, but in all industry sectors, for example, mining or the food industry, agricultural industry. And what becomes very obvious is that applying artificial intelligence, for example, machine learning and neural networks, is a top-ranked technology. And this is something we are addressing in our research at UTS. And of course, the foundation for that is connectivity. And I mean, we can see here that if we are not only looking at manufacturing, the relevance of additive manufacturing is not as high as in manufacturing. So I would like to take you on a very brief tour into our research and training infrastructure, into our labs at UTS. And we've been very fortunate in the last years to receive a generous funding from the government in order to establish a cyber-physical production facility for industrial algae. And we are part of the, or member of the National Industry 4.0 Test Lab Network. And here you can see inside our lab, where we have 2 photobioreactors for actually growing algae, and for example, robot infrastructure for harvesting the algae. So this lab is highly automated, and in addition, fully linked to the internet, based on, in this case, we are relying on Siemens technology, which is Siemens hardware, latest standard of Siemens PLCs, and connecting our hardware to the internet using the Siemens MindSphere connectivity platform, and in parallel using a data science platform for the machine learning part. So this is a perfect sandbox to explore the potential of Industry 4.0. And the purpose of collecting data throughout the manufacturing process is, of course, applying data science for predictive modeling. And I like to call it industrial data science, as it combines machine learning, which is the interface of computer science and statistics. And within our faculty, we are very strong in that area in the School of Computer Science, and we combine that with manufacturing domain knowledge, which is production engineering. In the case of algae growing, it's actually expertise coming from our colleagues from science, from the climate cluster department. And together we are working on predicting the growth of biomass in algae, the absorption of carbon dioxide. And our long-term vision is to actually embed machine learning models, prediction models, into the control loop of growing algae industrially, which is embedding machine learning algorithms in the Siemens PLC. So this is the industrial data science research. I would like to show you another highlight. So we have successfully applied for an ARC Industrial Transformation Training Center on cobots in manufacturing together with University of Technology Queensland and Swinburne. And the whole idea is to deploy collaborative robotics in manufacturing. So you can see here 2 examples from our industry partners. We have industry partners here who are doing heavy welding. So you can see heavy robots here with high weight loads. But another area will be assembly of parts where we are using state-of-the-art lightweight robots, which will be part of the course. Last but not least, I would like to touch on the fourth technology I've mentioned, which is additive manufacturing. And for those who are not aware, we have really world-class infrastructure here in regard to additive manufacturing equipment at UTS Protospace. So we're doing research there for many years now. And as you can see, it's not only comprising the manufacturing process itself, but the complete life cycle with a strong focus on materials and actually designed for additive manufacturing. So I hope I could give you some evidence on the world-class research and training infrastructure we have available at UTS. And I can assure you, we have top-notch academic and technical staff supporting this infrastructure. But as we have heard from Nicolette already, preparing graduates for the world of advanced manufacturing and Industry 4.0 requires much more than technology, but rather skills and competencies. And at that point, I would like to hand over to my colleague, Dr. Mickey Clement.
Thanks, Jochen. This pairs very nicely into discussing the curriculum, and the same World Economic Forum that surveyed companies to see what skills they're looking for in applicants and employees in long-term management of their own industries and business match very well with our curriculum. And so we can see here some things highlighted: critical thinking, analysis, problem solving, technical use and development, as well as among a number of other competencies. And these skills are practiced. These are something that has to be developed over time and practiced, and get better and better as you add more expertise to them. So that's why experience in employees is highly valued, because they have the critical thinking skills and the domain expertise to bring those together to solve problems that are relevant to the business. And so we've captured this in our curriculum. And next slide, please, Jochen. And so this suite of skills that we've heard from repeated over and over among the speakers, and I'm sure recognized by many of our industry colleagues here, are highly in demand. And how do we bring this into the manufacturing sphere? How do we add this into the curriculum and do that upskilling to bridge the theory? There's theory that goes along with analytical thinking, with critical thinking, and problem solving that can be added to the innate or experience-based learning that goes on the job. And we've added that theory in the context of advanced manufacturing with the skill sets that are relevant to bridging that gap between modern manufacturing or current manufacturing practices and the new development that utilizes and brings in these new software, IT, and technological changes that are occurring. Next slide, please. And so our curriculum is really broken down into 4 themes. And this is, we're talking today about the associate degree in advanced manufacturing, which is targeted at a 2-year time frame. But it sits in a broader context. It sits in a broader context of the research expertise at UTS and additional training opportunities that we are developing in parallel and that this ADAM degree builds into. And so these skill areas, naturally you need some basis in industrial and manufacturing engineering to understand the production system that these tools are applied to, and to optimize sort of the fundamental skills there are critical in any production environment. As well as data management and analysis, automation, robotics. These two components combined with the industrial and manufacturing engineering give us that Industry 4.0 idea that Jochen introduced earlier and talked about some of the work that we're doing. But there's another layer of it, and that's the complex system management. And this is where the theory of problem solving is at a much deeper level than the experience that you may get just sort of working through a typical degree. Thanks. And so we've organized this into these 4 themes, and we've organized it by session in terms of what a student may progress through. And this is this is our proposed curriculum. Some students may come in with some background knowledge, and that can be recognized to, skip subjects here and there and tailor the learning experience to that individual student so they can pass through this curriculum for the elements that are important to them. You may see sort of light on the screen here, the flow chart here. Those are sort of dependencies, skills that you need to gain before you enter into the subjects as it progresses through the curriculum. And so they do build on each other. This is a suite of courses that build progressively as you advance through the session. We don't have the delivery mode settled. And that's part of what we want to foster a conversation with you, both industry partners and employees, as to what is the best model that works. We have the curriculum in terms of the content that is informed by these global studies, Australian-based studies, and advanced manufacturing focused studies on what skills are important. In the context as well of what our research shows is important and the expertise that we have at UTS. The delivery mode itself is flexible though. And so that's really an opportunity for us to build something together that is workable for employees and employers and supports that collaboration that Nicolette mentioned. A nice visual for that is something that I enjoy is the rowing in the same direction. If we're all on a boat and we're rowing in different directions, it's hard to get the boat to move forward. And so we need to all row in the same direction. In terms of the content, we're fairly well established on what content will support production engineering, the advancement and the adoption of Industry 4.0 technologies. And now we need to develop together the delivery mechanism that works best. I think I can leave it there. Oh, yes, last slide. Thank you for the slides. We'll open up to discussion. This is a very perhaps enticing slide. This is a flavor. We're building one of these. This is our incoming Industry 4.0 brewery. And so we will have one of these shortly here at UTS to couple together with our algae lab. They use similar methods, and the cyber-physical architecture, the Industry 4.0 technologies, the approach that you take to these two different industries, brewing and algae growth, are similar. And so we will have cross-learning across those things, as well as a physical twin in Germany. I'll hand it back to Rob to moderate.
Thank you, Jochen. Thank you, Mickey. And look, I'll go straight to one of the questions. Jochen or Mickey, either one of you jump in on here that's come in. There was a slide that showed emerging skills, and the question is teamwork and collaboration part of a mix of emerging skills?
I guess I wouldn't say that they're emerging. They've always been a necessary skill, particularly in engineering. They may perhaps be even more critical in advanced technologies because there's no one person that can master all of the skill sets that are required to excel in the complexity of production in modern processes. My research is in additive manufacturing, and that is very clear in that you need all of the skills, software, materials, manufacturing, just in that one field, and I'm sure that's consistent across industries.
I might have an additional comment to that question, which is teamwork between different disciplines, which becomes more and more critical to success of deploying Industry 4.0. So I'm doing a lot of engineering consulting in German companies, and they keep hiring more and more computer scientists and data scientists. The only problem is, though, that these guys speak a completely different language to the experienced domain experts in process engineering and production engineering, and that makes teamwork really difficult. And exactly that type of teamwork and the skills and the cross-domain expertise, that's what we want to establish in our graduates of the add-in degree, that will actually get students trained who are capable to bridge that gap.
Thank you both. There are other questions, either raise hand or I think given that everyone's a bit quiet at the moment, I'd be, Philip, I can see your hand. Where you go?
Yeah, great. Look, my son has a diploma in electrical engineering from TAFE. Can you hear me? Yeah, good.
Yes, we can.
Great. It has a diploma in electrical engineering from TAFE and has worked with like PLCs and robots, etc. He's fairly familiar with the hardware and the software. I'm just wondering, what would this program offer someone like that, who in a sense is already in the industrial automation field and already has a diploma in electrical engineering? I know that he is interested in doing further study, but I'm particularly, because there will be other people like that in that category for sure, who will find out about this. So I'd just be really interested to get your ideas on that, please.
Yeah. Rob, would you like me to answer?
Yeah, please, Jochen, away you go.
Yeah. Okay. So you might be aware that Industry 4.0 has been called the fourth industrial revolution. Yep. So the third one was basically automation and robotics, part of it, and of course the whole PLC thing. And what makes it the fourth revolution is basically the connectivity to the internet, which is the Internet of Things, and the introduction to artificial intelligence. And you might be aware that sensor technology and the machine intelligence based on these technologies has significantly increased in the last years. And this is something which did not come with a traditional degree in automation. So I would say the add-on on traditional automation technology, what we offer in our course is the connectivity part, the Internet of Things technology, and on top of that, it's really learning about the potential and the technologies of artificial and machine learning applied in the area of manufacturing, which is the new component of this skill set.
Thank you. Thank you.
Can I add something there? Because we actually had trainees in our program that either did a degree in electrical engineering or in electronics pre-qualifications. We even had someone who had a apprenticeship in warehousing and logistics, and we completely re-skilled him from warehouse and logistics into Industry 4.0. So I really think if he wants to study, or a student wants to study, that the convergence of technology is coming. We're going to need mechanical and electrical and electronic, all of them to kind of redo a bit of reskilling and ongoing learning to create that skill of the future. The different base level skill that they have will of course help them with that that knowledge, or that in-depth knowledge they have in a specific area, but they will adapt new skills. So if he's interested in studying something further, I would rather recommend this than to go more deeper into what he studied already. So I would rather diversify the skills than to dig deeper into that.
Right, thank you.
I think I'll just add an extra thread in there, because I'm empathetic about people that have come through the TAFE system and studied electrical engineering. I was one of them, and I agree with both what Jochen and Nicolette have said. You know, the stepping stone from the TAFE qualification into this sub-bachelor qualification, and that's what an associate degree is. It's a step sort of a small bit below a full bachelor's qualification is actually a really good stepping stone, and one that we're you know, playing our part in developing. Okay, are there sorry, are there other questions?
There's a couple in the chat here. There's one about some of the subjects are seem similar to other engineering discipline degrees, and that's intentional. There is some foundational math and physics that is necessary to understand machine learning, to understand material manipulation, which is central to manufacturing. You can't avoid that. So there's some skills there that need to be developed, and it is the foundation that these more advanced, I mean, the advanced and advanced manufacturing is the application of these sort of base skills and the further development of them with these specific models. And so, yes, definitely there's some crossover with other engineering disciplines, math, physics, basic electronics, basic materials. Definitely there's some crossover there. And so you'll get that in any engineering degree, no matter the specialization. I guess on that note, there's so this Atom is designed to be 2 years, and we've put it inside of a 3-year broader degree. So that goes even a little bit more in depth, a little bit more expanded skill set that is an option as well for students who want to continue.
Zach, I can see your microphone on. Did you just want to add something there, or?
No, I'm good. Sorry, I'm on the phone. I'm not sure what's going on.
Okay, sorry, Zach. I saw you flash up, and I just thought you wanted to jump in. Look, I'm going to jump in here and say, for some time now, you've heard from us, which was kind of important. You needed to get a bit of a sense of what our thinking is, and I imagine you've got lots of questions. One of the key things we're very keen to hear is around this notion of co-construction. We need to hear and understand, I guess, some of your framework, your life, how this works in. Mickey mentioned some of the delivery there. I'd be keen to hear comments, even if they're not questions, about where some of this resonates with you, or what barriers you might be seeing here. Again, we've got Zach here from the DESE, who are the sponsoring organizer, or, you know, the government sponsoring from this. We've got Nicolette, who has had experience before in what these look like, and we're keen to hear from you, so please use the opportunity.
I believe there was there was another question from the audience, Rob. Ian Edwards asked, what exposure do students get to technology in support of learning IoT and machine learning? And just to give you an example, we have basically planned to do a lot of studios and experiential learning topics in our course. And one part for the IoT is we have 12 training workstations based on Baluf hardware and open source software, where all students are supposed to actually design and implement a cyber physical system on their own. So this is really learning based on doing things and hands-on doing. So that will be a very strong and important part of the curriculum.
Thanks, Jochen. I can see Ed Coe has got your hand up. So Ed.
Oh, hey, Rob. Yeah, I just wanted to sort of chip in and just sort of take up that call that you put out to give some insight and sort of personal perception around what you guys are presenting. So it's very interesting to me. So I'm a industrial designer. So additive manufacturing is basically day in, day out, you know, for us as a studio. And what Nicolette sort of spoke around soft skills and leaning into innovation, the climate in Australia is definitely very much so. You know, we have to rely on these new forms of manufacturing or industries that sort of elevates us. Sorry, it's going to close the window. So one thing that I was interested in about this specific program, and maybe there is something I've missed, is there any direct discussion around how to bridge traditional manufacturing with additive manufacturing? Because in our context, additive manufacturing, you know, to a client is this space age technology that's 3D printing metals, all sorts of things. But to us, it's almost seen as a viable alternative to large-scale injection molding, for example, you know, where it does bridge this gap of cost and risk that we encounter quite a bit within the industry. So just wondering if there's anything specific in this module of study, because that's something that's very interesting to us right now.
Well, I mean, when we think additive manufacturing, we're thinking in value streams, in process chains, and I've never seen an additive manufacturing application in industry which lead to a final product in regard to industrial production. So you always have machining involved in many cases for sequencing process steps. You have a lot of material testing and qualification in there. And that's why, as Mickey has mentioned, we kept some fundamentals of manufacturing in the course, in the ADAM curriculum, because we want to make the students think in process chains instead of singular processes. So it's definitely additive manufacturing, not only in terms of prototyping, but rather industrial serious production. And in parallel, we are working with some colleagues in Germany who are really experts in machining, in forming, on manufacturing process chains for industrial production, including additive manufacturing. Does that make sense?
Yes, it does. It definitely does. So is there anything you can expand on specifically around materials as well? Because that seems to be one of the limitations that we also come up with in advocating for additive manufacturing in, you know, for example, in prototyping scenarios. So is there something that can be explored or will be explored within the course for specifically material based?
Mickey, over to you. You're the expert.
Yeah. So there is a whole subject dedicated to additive manufacturing. So not just in the context of the learnings about production systems and value chains and business decisions about what manufacturing process is best for a specific application, but also about the specific technology, the material options, you know, the in-depth grounding of what additive manufacturing can do and is possible for, and that sits alongside, you know, the other industrial engineering learnings that are going on, as well as the sensors and the machine learning. So yeah, there's definitely space for that in-depth study.
This is also, if I may, Rob, this is also where the stakeholders come in and the employers come in, right? So the UTS can do the curriculum and put all of that in, but imagine it's someone working in your site and then actually studying this program. You know, that can bring value to you, but that student also brings value to the curriculum. And the curriculum, this is not, you know, something we found with the pilot, it is not a curriculum that has to stay the same every year. It's going to have to move much faster. You know, perhaps, and I'm not an academic, but, you know, we didn't review our curriculums. I mean, of course, we reviewed it, but this will need refreshing. This technology, the one thing about the fourth industrial revolution is moving faster, more complex than any other industrial revolution. And therefore, from an education and in an office, a work point of view, we need to adapt faster and more complex. And bringing those people in and bringing people like you and your company into the program will also support the faster development of the curriculum in certain directions. I think that's very important. And then maybe you can explore with the UTS team in terms of the digital twin and what in the software, in the MindSphere environment, what the digital twin from a Siemens point of view can do for you there, how you can test certain chemicals or certain scenarios. You know, the Mars rover is the prototype. I mean, you know, there was not a second one built because it was built digitally. So there's a lot that can be done with the software also that UTS have, but they will need the industry to come with their ideas, come with their problems, that it can actually feed the curriculum to give those problems to students to solve. And who knows, they might just solve something for you that expand your business. And I think this is the important part where Rob says it's now time for you to join. This is where I think the UTS can roll out this curriculum, but without employers, without industry, the curriculum is just another training program with a certificate.
Thanks, Nicolette, and thanks for the responses, everyone. Ed, I hope that's helped. I'm aware there's a couple of questions that I'd like to get to in just a moment, which sort of are around the duration of the program and prerequisite knowledge. But Alex from Downer, you've got a question?
Yeah, thanks. I don't know if you can hear me, Rob.
Yep, away you go, Alex.
Oh, awesome. Thanks. Yeah, great presentation. There were a couple of important points that came up. We tend to support a lot of our up-and-coming students in these courses, and a course like this would be just unbelievable to be able to bring to life. The couple of questions were around traveling interstate and how the course would be constructed. If they're not from the New South Wales region, visiting the actual university and delivering projects is something to consider. We don't have to solve all of them here, but what is the portion between online versus physical, pitched at the level of giving students time off and employees time off to actually travel and deliver on that. The other one is the difference between high-level managers versus up-and-coming graduates, and how do we pitch the difference in content for a highly experienced Industry 4.0 manufacturer versus a student who's being introduced to some of those new notions. And the other question, and it's again not for answering here, it's just for notes, is how do we teach the up-and-coming kids to learn about aptitude and working in a collaborative role? A lot of the industries, it still comes across as competitive and siloed. I sit on the Industry 4.0 forum with Minister Karen Andrews for the Gold Coast, and I'm meeting new collaborative partners on a weekly basis. So how does the course offer the opportunity to actually create a network of up-and-coming graduates who understand that collaboration is the most important part? And if we all work together and we all understand the outcomes for every individual rather than our own sort of outcome, how much better that is from a networking opportunity rather than a single discipline view. So that were just my comments to the panel.
They're very helpful, Alex. Thank you. And I think in the interest, and I understand some of them will take a little bit time to respond to, and I don't intend to do that now, but I will just flip some of those a little bit and say, I'll take on notice that you're saying you would like students to be able to attend or to be able to go through a program in a mode which generally suits you as an employer, and that's well noted. That's something that we were aware of as well. Can I point to one of the questions which was around prerequisites or coming into this? The three main components, well, two main components are around sort of prerequisite knowledge or skills. There's an assumed level of some high school maths, which is in that. But at UTS, we have a pathway in that says if your high school maths is relatively poor, then we have a maths pathway, available for you. So it basically helps build your skills in that first session of studies and then gets you on track to be able to continue with that pathway. And English language, this program is opened for domestic students only. There's an assumption there of, that students are either working or have English as studied a year or more in some sort of mode, whether it's HSC or school or tertiary study in English. And I think most of our applicants are going to fall into that. Barring that, the IELTS score is 6.5 to come in, which is relatively competent English language. And I think this course will be most attractive for the Cert 4 or diploma kind of graduate, the people that have had something in TAFE previously. And they may have actually even done or be a current UTS student or university student that's looking at this and saying, wow, that looks like an option for me. And if that's the case and you're seeing some of those subjects out there that you might get recognition of prior learning for, as Mickey alluded to earlier, that is absolutely possible. The point that I will make is that we will roll this program out commencing from the beginning of next year, which means not all subjects are going to be available at all times. As a cohort starts to go through, we will prepare and deliver those subjects. So if you have too much recognition of advanced learning and you find yourself trying to get into year 2 of this program, we won't be offering that until 2022. I think they're the main points. Was there anything else, Mickey, you wanted to add to that?
No, I think that's good. There's a question about micro-credentials, and yes, we're developing micro-credentials in parallel because not everyone needs all of the skills or looking for all of this, you know, the full suite, you know, specific things that are targeted, and we have those coming online as well.
And I've got a feeling there was a comment elsewhere in there that said maybe not everybody needs to have the 2-year associate degree. So the micro-credentials lend themselves very well to maybe that middle management or senior areas of an organization that might not have the time to do a 2-year full-time degree, but definitely need to get some of the language or understanding of that. So that skilling up aspect, and I think that's where micro-credentials will lend themselves very nicely.
Perfect. Thanks very much, Rob.
Thank you, Alex, and they're good points, well noted. Are there any other comments or questions from the audience?
I guess one thing we didn't talk much about is the work integrated learning and how that actually happens. Nicolette mentioned bringing the projects to the curriculum. That is key, right? So our curriculum is meant to teach you ways of thinking, ways of approaching problems. The problems themselves come from industry directly, either from our partners or from the employers who are participating in the program. And so we have a number of industry partners across the Center for Advanced Manufacturing that we can draw from, as well as employers who are sending employees or employees that have specific challenges. The ways of thinking that we're teaching you and the skills that will enable solutions that weren't previously known in your field. That's what this curriculum is about, and so it's meant to be highly coupled with your the industries that you're working in.
Rob, if I can just say, because I think it's important that people know this, what Mickey has said there. What we also found that there were some things we couldn't offer, and we worked with our supply chain and and for that part of the curriculum, our trainees went to that company, and then for a part of the curriculum, they came to us. So I think, and I think Alex was referring to that earlier, it's important that we all look in our value chains and our supply chains and say, who can I collaborate with? Because I might not bring, and same for Ed, I might not bring the whole workplace that can train that curriculum, but can I engage with the Siemens and say, Siemens, this is my trainee, I'm gonna, we think it's impossible, but it's possible. I'm gonna let them come and do their practical with you for the next 6 weeks or 8 weeks for that specific piece of training. And then you bring yours to us for this specific piece of the training. And this is really where we really need to break down, similar to what Alex has said, the barriers of industry and everyone just playing in their own area. We need to work together and collaborate to bring a curriculum like this to life.
Thanks, Nicolette. There was a question that I think I missed earlier in the chat room, which was really around part-time. The program's been designed to be rolled out in effectively 2-year full-time mode. There is some flexibility, as Zach was talking about earlier, to be able to change that to a part-time friendly mode. What we're keen to hear from participants or potential participants in this is about what their I guess flexibility or availability is going to be like to be able to go through a program like this. So if you're saying, for me, I would absolutely be on board, but it needs to be part-time, we need to hear that so that we can help start working out our delivery models. I'm conscious of the time. I don't necessarily want to stop this because there's not been too many people that have dropped down. But I have a couple of closing comments. But before I do that, I just want to leave it open for one more question, if there are any.
Yes.
Hey, Philip.
Yeah. When will the full documentation about the course be available online?
As soon as I can get it through our central approvals. You know, we're a self-accrediting organisation. I'm absolutely pedaling hard to get that as done as quickly as I can, Philip. Yeah. So ordinarily, any other time in a university setting, we would have had all of this stuff wrapped up in about February, the year before we would launch this program. We are building this literally on the fly at the moment, and so we are trying to break as many rules as we possibly can and being as agile as we can to get it up and running for February.
Right.
And now that we've connected with many people here, of course, we'll be keeping our website up to date, and we'll also be following up with you via emails, etc., and keeping you abreast of our pathway through that as we go. Okay, I think I'll need to wrap up here. I believe some of the panel at least might like to, will be available to hang around a little bit after this, but I'd like to bring this to a close. As I've just mentioned, we will be following up with everybody via email, and if there are others that you want us to connect with that you think should, then please ask them to contact us and give them their contact details via the email address for this program. Where in terms of applying for this, we'll put this information on the website as well. We're preparing what's going to be an expression of interest pathway. So if you're planning to apply, we're going to need, or we'd like to see a, if you like, a motivation letter, or this is why and my aspirations for coming into this degree. It needn't be a lengthy assessment task. It is simply, this is me and this is where I want to get to and why I want to do it. Since you're employed, it would be good to have a employer support letter along with that that says, yes, we acknowledge that that this person is going to come into this, and that there will be a bit of an expectation there about recognizing that this person's going to be going through a program with us, as well as staying employed and what that would look like. We'd like to articulate as best as you can your study schedule availability. So if you've got the type of employer that is saying, we'd very happily go back to the sandwich pattern, which is what I went through, which says, my employer is happy to have me go to study for a full-time package, full-time semester, and then come back and work during breaks, or work for the remainder of the year and then on and off again, then we need to know that. If it's strictly part-time, we need to know that. If it's block release, 1 day a week, we need to know that. So we want to hear from you what your schedule availability is. And if you've applied previously through the UAC systems, the University Admission Centre, into a tertiary course, then we'd like to know what your UAC ID was. And if you don't necessarily know that straight off the hand, that's okay. Just say that you applied for a particular degree or you've previously come through UAC. That would help us with our application process. Right, so I think that brings the critical announcements. I think I need to close off here. As I said, I think there's a few panel members that will be prepared to stay behind and answer further questions. I'd like to thank you all for staying on and hearing from us our story. Thank you for your questions. They're engaging and thought-provoking. They've been very good. Without any further, I think I'll call it to a close. So thank you very much.